Okay, so in the next question we've got 4 different rate graphs which have not been labelled on their axes. So the first one is asking you which one's going to be a zero order reaction where you're plotting concentration against against time. So here you're wanting, since you've got concentration against time, your gradient is going to be equal to the rate. So if it's zero order, that means the rate is not changing. So you want a gradient that is constant. And in this case, if I looked at this straight line, the gradient is constant. So my gradient at point 1, if I calculated it, would be exactly the same as my gradient at point 2. This leaves me with an option of B or D. Well, the answer can't be D for 2 reasons. Number 1, because it says the concentration of the reactant. And we know that the reactant is going to be used up as the products are formed. So therefore my concentration of reactant is going to decrease over time, not increase. Second thing to say is my concentration of reactant doesn't start at 0. So therefore it can't be D. It can't be A because it's not a constant gradient. It can't be C because it's not a constant gradient. So therefore it is B. Okay, the second one's asking you for which one could be a rate of reaction on the vertical axis against concentration on the other axis for a first order reaction. Well, we know for a first order reaction, as we double the concentration, the rate is going to double as well. So we know that the concentration is directly proportional to rate. And we know that as we increase the concentration, we're going to increase the rate. So we're looking for a straight line graph with a positive gradient. The only one which fits that criteria is D. So the answer is D. In the third example, we're looking for exactly the same, except where it's the square. Well, if it's the square, obviously my order is going to be raised to 2. So again, it's going to be directly proportional. And again, it is going to be D. Okay, which could be the graph, the concentration of a reactant on the vertical axis against a reaction which has been catalyzed by a product. Well, remember initially that as we're catalyzing, we're going to have an impact on the rate. As we proceed, the impact on the rate is going to decrease because we've got adsorption. So the catalyst bed is being completely blocked and therefore no further reactant can react to make your product quickly enough. So we're looking for a graph where the gradient gradually approaches closer to 0. Okay, and the only one that fits that criteria is C. We can see that gradually in A, the gradient is approaching infinity, not approaching 0. Okay, and initially, in C, the reaction is not going to happen. Then the reaction is going to happen quickly as we add the catalyst, and then as the catalyst bed gets blocked up because of adsorption, the rate's going to decrease again. So it's C.